Okay, so that's the tear debris sorted out. What I want to do now is I want to do something similar to basically test for geometry impacts when the geometry hits the ground. So when, for example, if I just scrub forward, let's just pull that across a little bit. It's updating a little bit slowly because of the recording software, and it's also having to redraw the entire thing. Here we go. So when these guys kind of hit the ground, what I want to do is have some some particle debris impacts. Okay, so to do that, similar kind of procedure what we've already got established in here. So what I can simply do is use some of the system that I've already got set up in here within a new one. So I'm gonna just go back to frame 0. So this new system I'm going to create is just going to be a standard. I'm just going to put an empty flow in there. I'm going to rename this guy. Let's call it PF source. Let's call it PF source impacts. There we go. And we've already got the same kind of properties that we've already set up in previous event. We've got the quantity multipliers currently set to 100 in the viewport and 100 in render time, and we are using high upper limit, and the integration step is set. However, what I want to do is I'm going to set the viewport percentage back down to 1% again. Okay, so we don't obviously need to deal with a fair amount of particles in the viewport. We only need to deal with a few. Alright, so similar kind of process as we had before. So I'm just going to grab this guy here and I'm simply just going to copy that across. Okay, we don't need to do the entire speed test thing this time, so we just need to test for collisions, so therefore this can actually go. Alright, so in here what I want to do is I actually want to set the amount of particles to, let's say, about 100,000. Alright, and then wire the system together, and then this thing I need to rename. Let's call that impact debris placement. Alright, position object I think we can leave as is. However, I'm just going to set a new seed in there, and I think the location I'm actually going to set to surface. Alright, so it's over the entire surface of the geometry, not just the edges. The reason, like I say, we did it in the edges previously is so it gave the indication that the particles were being positioned between the slats. Okay, if we did it over the surface, it would look like the particles were actually coming out from in the middle of the slats, which wouldn't work as well. However, these guys, because they're going to be interacting with the ground surface, i.e. this collision test, so just copy this guy here and then instance it across to there. We basically need the entire surface of the geometry to be checked. Okay, so because we're dealing with debris that's generated by object to soil impacts, we can actually create I think we'll actually use a higher value in this, because this is kind of dust matter. We actually want kind of soil impacts. So I think we'll use a new shape operator in here. So this one I think we'll actually drop that down to a value of 1, which is obviously going to be bigger than this but smaller than this guy. So then I'm going to wire that into there. Okay, and I'm going to change this here to dots again, and this particular color I think we'll actually set to a kind of like a dark brown, something like a value of like about 90, 70, 50, something like that. That works quite well. Okay, same kind of principle as before. Actually, let's make sure we've got this set to cube. Right, same principle as before. We need to set a scale in here, and I'm going to set that to a random variation of 50 for all axes. Next thing we need to introduce is a spin in there as well, so when the debris kind of gets flung outwards it's kind of spinning a little bit. So let's drop that guy in there as well, and this one I want to set the spin rate to let's say about 250 with a variation of 100 in there. Okay, next thing we basically need to introduce is a dispersal pattern. Because we're dealing with particles which are going to be hitting this deflector, the resulting bounce isn't going to be that high, so we need to kind of inherit the impact direction and then exaggerate it somewhat. So to do that, what I'm going to do is add in a speed operator in here, and I'm going to set the speed value to about 20 with a variation of 20, and I set the direction to inherit previous. So we get a wide spread. I'm actually going to set this divergence value to quite a high value of 60, so we're getting a very kind of nice distribution coming out here like that. Alright, because we are now producing debris and dust and so on, we obviously need to have these guys being picked up by the vortex as well. So what we can do is we can simply just introduce another force operator and loading in the vortex dust and the wind dust as well. Alright, same principle as before. It's a little bit too strong, so what I'm going to do is I'm going to take the strength of that guy down to 500. And one last thing is, because obviously we're dealing with largish debris, well, not really large, but it's obviously larger than this guy over here, and we obviously want the soil to kind of travel back down to the earth. We'll drop in a gravity as well, so let's drag that guy in there and let's add in the gravity. Because we're obviously dealing with fine particular matter, let's say let's drop the influence. I think we'll actually set that down to about 40. Actually, maybe not that high. Let's take it down to about 30. So these guys are kind of coming down a little bit. It's going to be a little bit stronger than this because we're dealing with kind of rock. So in essence, it's going to be slightly heavier than this guy over here. Actually, you know what? I think I'll actually increase this up to about 40. Right, okay, that'll do. One last thing I need to introduce, which is then going to tie into the next system I'm going to build. That is going to be another copy of this, well, another instance of this collision test. Now what that enables us to do, when it hits the deck again, it can basically check for collision impacts. When a chunk of soil hits the ground, it can break up into separate fragments, which is basically what we're going to set up into this next system, so it all kind of shares within. Same kind of principle as what we had in these guys over here. We can basically check to see whether or not the debris is moving or not, and whether or not it needs to be re-picked up by the vortex. So let's go ahead and set that up now. So with this particular one, what we need to do is we need to actually draw the initial particles which need to be sucked up by the vortex initially. Now to do that, we need to stick a large particle flow source around the base of our funnel and have that kind of draw particles out, which then, if they start moving, which are, if they're in essence being picked up by the vortex space warps, then they can basically get made renderable and then start being pulled into the funnel. If not, if they aren't basically being moved or affected by the space warps, then the particles will be deleted after a very short amount of time. Basically about 4 frames with a variation of 2 in there, something like that. So this is pretty much the impacts one setup. I think what we'll do at this stage is I'm just going to go through and I'm going to save the system, or save the scene even, sorry, and I'm just going to scrub forward a little bit. Let's put it to about frame 40. Let the thing update a little bit. You can see it updating down the bottom down here. And if I have a look in the front viewport, here we go. Just going to go forward there. Now you'll see some of these guys, obviously they're kind of locked onto the geometry at the moment, and when they hit the deflector you'll see it change state. You notice it's changed state over here, and it's now being picked up again by the there we go. You can see some of these guys over here as well. Obviously all this light is going to be picked up and piped into the next system, so they bounce, and then if they don't hit the deck the first time, they get sucked up, and then if they hit again, they break up into smaller particles still. So we get this nice kind of, if we go into the top view, we should have this nice kind of distribution pattern like this, which is something that we kind of see in reference. So we get this nice kind of trails coming in of debris that's been sucked in and distributed outwards, and then been sucked back in again into the vortex. Okay, so I'm just going to go back to frame 0, and I think what I'll do is I'll also disable this system as well while we design our next one. Okay.